This is the second video for Math 107 for homework number 7. On this problem, I want to see the steps written out. Otherwise, you won't get any credit. You'll get this, -1, just for writing the answer down. And why do I do something so utterly cruel and mean? Because I really don't care that you can come up with a quick answer. I want you to know the procedure. So here's how I want you to do it. First, use a binomial theorem for a binomial raised to the third power. So this is similar to what we started off before. So I've got a plus b cubed. Alright? So do the same thing. A's counting down, b counting up. A's going to 2, b up to 1, a to the first, b squared, and the last term, a is down to 0, and b is, 0, and b is cubed. Okay, you see a counting down, 3, 2, 1, and 0, that is a 0, and b counting up, 0, 1, 2, 3. Alright, and the coefficients, you put the fractions, and the fractions in the numerator is the power factorial. The power is 3. That's why the 3 goes here. 3 factorial, 3 factorial, 3 factorial, 3 factorial. In the denominator are the powers of the variables in the term factorial. So there's a 3 factorial here and a 0 factorial. Now I've got a 2 factorial and a 1 factorial. Kind of crowded under there. Now I have a 1 factorial here and a 2 factorial. Doesn't matter the order you write them because it's multiplication, and multiplication commutes. And now I have a 0 factorial, 3 factorial. By symmetry, there's not a lot of work to do. So for the first term, I have 3 factorial over 3 factorial times 0 factorial. 0 factorial is 1. So this is 3 factorial over 3 factorial. Those cancel. That's 1. B to the 0 is 1. So here's that first term. It's a cubed. Right? Now let's look at the second term. On the second term we have 3 factorial over 2 factorial times 1 factorial. 1 factorial is 1. So I've got 3 factorial. I'm doing all the steps so you can see it. This can count down to where I can cancel. Answer is 3. So for the second term it's 3, and that's all the calculation you have to do because of symmetry. You see, the term here is the same as this term, so its value is 3. So I have 3, and I have a b squared. Last term, this is the same as the first term. You know its value is 1. A to the 0 is also 1, so b cubed. And that's the answer there. Right, now I need some room, so I'm going to rewrite this a little bit. Now here's the second part of this problem. Go back to the original problem and make the following identification. A, the first variable, is equal to x. So I know a is x. And b is -y. Then looking at the solution I had for the binomial theorem, I substitute. Every place there's an a, I put an x. Every place there is a b, I put a -y. Be sure to use parentheses for that minus sign, because otherwise you might subtract it when you shouldn't. So now I'm working this problem. Now there's an a cubed, so this is x cubed. That's easy enough. There's an a squared, so that becomes x squared. B is -y, but remember those are multiplied. For the next term, I've got just x, but now I have the -y squared, and the last term is -y cubed. Now work out the algebra there. X cubed stays the same. Now I have 3 times x squared times the -y squared. Well, that makes the whole term negative, minus 3x squared y. Now what is -y squared? That is y squared, because the negative sign will go away. So I have 3xy squared. In the last term, if you cube a negative number, it remains negative, so -y cubed. Right, for this problem, I don't want to see this answer by itself. I want to see the work. Right. Now here we have another binomial to the third power again. The instructions say you can use the results from the work above. So let's write that out again. Well, to save time, I'll just write that and pausing the screen. In this case, we make the identification that A is going to be 2x and B equals 3y. If you think this is a complicated problem, previously it was minus 3y. So I simplified it. Okay, so now I want to work out this problem using that template that I created for a plus b cubed. So I have 2x plus 3y cubed. Every place there's an a, I put a 2x. Use parentheses. So I've got 2x squared multiplying 3y. The next term is 3. I just got plain old 2x, but I have 3y squared, and the last term, 3y cubed. I think I said this before, it's worth repeating. You might need more room. Go do this on a separate piece of paper and write out all the terms with lots of space between them. You start getting all cramped and crowded and writing over, that's where errors happen. Plus I can't see what you did when I go to correct it. Okay, so now I need to work out these terms. 2x cubed is 2x times 2x times 2x. This is a monomial. You bring that, if you want to do it shorthand way, you can bring that 3, that cube, to both of those terms. So in the first case, 2 cubed is 8, and x cubed is like that. For the next, I'm going to have 3 times, now 2x times 2x is 4x squared, and then the 3y. For the next term, the 2x is like that, but I have 3y squared. That means the 3 and the y both get squared, and there's your 9y squared. The last term is 3 cubed, which is 27, times y cubed. Now remember that there's multiplication here except for those plus and minus signs, the plus signs between the terms. First term, 8x cubed. Now in this case, I multiply 3 times 4 times 3. It gives me a whole 36. X squared y. Now I have to multiply 3 times 2 times 9. Okay, so get 54 in this case. Xy squared. And now here's my last term, 27y cubed. Notice the nice symmetry we have up here, which you might recall from Pascal's triangle, the 1, 3, 3, 1. Once you get these some coefficients onto the terms in the binomial, you lose all that symmetry. 8, 36, 54, and then 27. Now we have sigma notation. Remember the factorial was associated with multiplication. Sigma is associated with addition. I'm going to go through and do this with brute force, and brute force means just substitute and go. Right? So when n is 0, I put n into this equation. First term is n times 0 minus 1. Then I add, increment the counter to 1, and I get 4 times 1 minus 1, and then just keep going. It's already getting boring. Okay, 4 times 2 minus 1, 4 times 3 minus 1, 4 times 4 minus 1, whoops, that was a 1, and then 4 times 5 minus 1. Alright, what did I do? Here's the n, that's my counter. It appears here. As I move through the sigma, n changes from 0 to 0, 1, 2, 3, 4, 5 stops at 5. 5 is the max, 0 is the start. Let me underline the counter in red. Here's a counter going up. 2, 3, 4, 5. Alright? And so you put it in the term, then you add, increment the counter, add, increment the counter, add, increment the counter like that. That is brute force, just substituting and going for it. I hope you understand that much. But there's a different way to do the problem, and that's to remember that sigma breaks at the plus and minus signs, and then coefficients, if they multiply everything, can come out in front. So let's do it that way. Okay, sigma breaks at a plus and minus sign. So I have the same sum from 0 to 5, and all I have is a 4 in here, minus the sum over just the number 1, n equals 0 to 5, right? Because that's the 4 is multiplying everything, it can come out in front. So I have 4 times the sum from 0 to 5, that's an equal sign, of n, minus this sum. When you break it out like this, you have to know a little bit more about the sigma notation, times 1. Okay, so this is 4 times that sum. So it's 4 times 0 plus 1 plus 2 plus 3 plus 4 plus 5. Okay, you just add all those up and you'll multiply by 4. Watch it, 4 multiplies that whole sum, so you need parentheses there. Alright, now when you get to this term, there's a minus. Okay, what this means is add up 1, but increment the counter from 0 to 5. So how many terms are there? There's 6. So you can write the number of terms as 5 minus 0, the top of the counter minus the start, and then have to add 1 to it because you're counting 0, 1, 2, 3, 4, 5, gives you 6 terms, times 1. And now when you work out that arithmetic, that's the answer. All right. Let's try this one for the rest of this video. Notice the 4 multiplies everything, so I put that out in front. And then I'm going from 3 to 6 of n minus n squared. Okay, now the sigma can break here, so I'm going to do that. So I have the 4, I can put this in parentheses. I've got the same sum from 3 to 6 of n minus the sum from 3 to 6 of n squared. Now I can expand this. So I've got 4, and in the parentheses I have the counter's going from 3 to 6. That's n, 3 plus 4 plus 5 plus 6. That's that first term. Then I subtract from that, and now you see the counter again going from 3 to 6, but this time it's squared, n squared. So 3 squared plus 4 squared plus 5 squared plus 6 squared. Now you can go work that out on a calculator as you wish. I don't really care. This is what I want to see. I want to see you be able to get from here to this point showing the steps.